Hey everybody, my name's Courtney and I'm here with Gloria, and we did a paper on machine learning and how it's taking over the fashion industry. All right, so here's what's on the agenda. We're going to go over a brief history of the topic that we chose, and then we're going to show you guys our layout for our design or approach that we're taking, and then we'll give you a little demonstration of a neural network that we found that we'll use in MATLAB. And then we'll also show you this one interesting site that we found that's also kind of related to our topic. And then finally our conclusion. Okay, so here's a brief history on the topic that we chose. We chose to go with something that kind of incorporates fashion and technology. We found that very interesting. Some existing machine learning models that are out there. We found a couple of them, but the two main ones seem to be the Bayesian network model and category learning. And we chose to focus in on the Amazon Echo look. You can see some features of it to the right, but it was just cool to see how machine learning and technology came together to really have an impact in people's day-to-day lives, if they choose to use it, obviously. And finally, some other styling artificial intelligence that we saw that were out there on the internet include Stylely and Thread.
So clearly we don't have access to Amazon's algorithms, but we did a lot of research, and so just a little bit about the Amazon Echo look. What it's able to do is take pictures of you or a 6-second video, and then it stores it where you can review that later. Additionally, there's also the capability to select two outfits and then compare them, except you're not comparing them. Amazon Echo Look is actually comparing the outfits, and chooses one based on AI and actual stylists that had trained it. So what we saw that it was very limited, and it really catered to a very select group of people. And so we saw an immense room for growth and opportunity to further use machine learning and, give the user and give even more users a better experience with the Amazon Echo Look. So we really see this technology as the first of its kind. And in addition to the existing inputs, these right here, you can see the other inputs that we have proposed, and they're really in three groups: external factors, the personable factor, and just wardrobe items. So for external factors, that would be weather, time of day, time of year, and location. So say you live in a warm area and it's summer, then obviously if you're wearing a jacket and you're wearing long pants, Alexa, which is, the voice for the Amazon Echo Look, will suggest for you to, are you sure you don't want to wear sandals right there? The next group would be the personal factor, which really is the user event and user mood, I guess, and also preferences. So obviously if you are talking to Alexa, and we're hoping that Alexa will be more conversational, so you wake up and you say, I have an interview today. And that would be different than if you had woken up and said, oh, I'm relaxing all day, or I'm just going to the mall. Then, of course, your outfit would correspond accordingly, versus just what they have now, where it's just AI and the stylist. This really takes into account the user as a person, where it's customized to who the user is. And then finally, it would be item by item. So that's just closet items. So instead of just the stylist looking at what you have, or the AI looking at what you have, taken your pictures of your whole outfit, now it's every single bracelet, all your skirts. And so when it's an item like that, then it's easier to compare and also to even gather more information to help you. All right, now it's demonstration time. So since we don't have the code for the Amazon Echo Look and all that, we're just going to show you some of a neural network example. And the example data set that we are going to use is the engine. And so this has 1,199 data points of fuel rate and speed. So those are your two inputs fuel rate and speed, and your outputs and what you're predicting is torque and nitrous oxide emissions of the engine. All right. So 70% of the data, which is 839 samples, is going to go into training. 15% to validation and 15% to testing. Of course, you can change these as well. Number of hidden neurons, you can also change that, and this is just a little diagram to help you understand. Visualize. Alright, and so it's here, Levenberg McCart. We're going to train that. And now, really, we've got our neural network, and that was pretty simple and straightforward. Obviously, there's a lot that goes on behind the scenes. So we can see that here. This is basically if we were to write this out, but this did it for us. That was very nice. And here's the regression plot. This was very good. This would be awesome if we were to see values like this. And now we will go into and here's a cool site that mixes deep learning with fashion. So this is just a resource that we just wanted to share. So I guess in R, what we were using in class, that we could download this library, Algorithmia. But yeah.
Okay, and that is all that we have for you guys. Thanks for watching.